Welcome everyone, and thank you for joining our webinar today. My name is Taylor Colon and I am a Customer Engagement Specialist here at TestOil. I will be your host for today's presentation. Before we begin, I would like to tell you a few things. First, everyone is on mute. This is to ensure high quality recording. If you have any questions throughout the presentation, please feel free to use the questions box in your GoToWebinar application. We will be happy to answer those questions at the end of the webinar if we have time. If we cannot get all of your questions, we will answer those through email. As I mentioned before, we are recording this presentation. This recording will be distributed later along today with a survey. All right, so let's get started. Today's webinar, titled How to Employ Root Cause Analysis, will be presented by David Rosenthal. David has been a reliability consultant for over 25 years. He provides a wide range of maintenance and reliability consulting services aimed at designing asset care strategies that improve uptime and reduces operating costs. Before starting his own company, Dave spent a majority of his career with the Rome and Haas Company, a specialty chemical manufacturer. He has also served in reliability positions with Jacobs Engineering Group, Laxus, which produces bottle rubber, and with Kellogg's in their snack food division. Dave has a master's degree in chemical engineering and is a registered professional engineer and a certified maintenance and reliability professional. Dave, are you ready to take over?
I am.
All right.
Thank you very much for the introduction. I'd like to welcome everyone to this presentation of how to employ root cause analysis. This is a subject very near and dear to my heart because I really truly feel that a site that masters root cause analysis will be able to improve their reliability at their site and reduce operating costs. So the agenda for today, I want to start out with a brief safety moment. I think we've already gone through the introduction of myself. We'll talk about the objectives. We'll give a brief overview of reactive organizations and how to move from being reactive to proactive, and then why it is important to employ defect elimination tools to do that. Talk about a root cause analysis work process, and talk about the individual stages of the work process called preliminary, implementation, and closure. Talking about leading and lagging metrics to see that you are actually progressing in implementing a good root cause system. What kind of results can you expect? And of course, time for questions. And being raised in the chemical industry, I was always trained to start every meeting discussion out with a safety moment, and I'll be a very brief one. And my brief safety moment today is basically to take safety home with you. Many of us in our workplace are well trained on various aspects of safety, whether it be preventing slips, trips, and falls, preventing hand injuries, and the like, and yet sometimes we go home and we forget about the lessons that are provided to us in the workplace. So I ask you to always remember to take safety home with you. Remember what you learned in the workplace. Wear the same type of PPE, doing chores around the house. Watch your ladder safety. Watch your spouse and your family and anybody else who is in your home and how their approach to various tasks, making sure they're safe. So again, always bring safety home with you. Oh, a little late on that slide, but again, safety, other aspects of safety that, of course, I'm sure all of you are trained on at work. And I think we've already gone through this introduction. The objectives for this presentation is to understand the importance of root cause analysis, why it's so important, how to do it right, and what it means to reliability. And also to provide a common sense approach to root cause analysis that can be performed given the demands on those restoring equipment function. And that's always been the trouble with root cause analysis. Sites get involved too much with doing too many root cause analyses, and what happens is people become overloaded, the results never really get remediated, and basically the same failures tend to occur all over again. The purpose of this presentation is to provide you a common sense way to really prioritize what needs to be to have a root cause analysis. Reactive maintenance. How can you tell a reactive maintenance organization? Well, these are the kinds of traits that they typically show. Number one is that breakdowns are commonplace and they're attended to at the expense of completing other planned maintenance tasks. And what happens is that all these breakdowns occur and it prevents the work that needs to be done to take care of the equipment from being accomplished. The various PMs and other predictive work, breakdowns just get in the way, and they certainly crowd the schedule, and they take away resources, and they just don't allow the right work to get done to prevent these failures in the future. And again, preventive work is not executed because just no time for it, since the breakdown work is just taking up all the resource time to accomplish. Downtime is prevalent due to breakdowns. Sites miss their production schedules, they miss client orders because their equipment is just not dependable and not predictable to achieve the goals of their supply chains. And you can also tell from a reactive organization because they have very few planned proactive maintenance tasks. Their majority of their tasks given to the mechanics are not well thought out, they're not well planned, and does not cover a lot of the equipment in the facility. Maintenance planners are active planning reactive work. That's the one thing you don't want a maintenance planner to do. Maintenance planners should be planning more of the proactive work in the site. Materials are not effectively managed. Stock is missing from the storeroom. It's unavailable to the maintenance people when they need it, and the like. Bill of materials are incomplete or don't exist. In other words, when you look on the site CMS system, the bill of materials list is often not attached to the right entities. It's not very complete, and it's in a shape that does not allow the easy requisition of materials. Technical information is not well managed. We all know that that engineers and others and maintenance people love to have their own separate private files, and all that information is not very well managed. Certainly it should be on the CMS system or some other good information technology system that the site can access the required information. And the last one, and one of the most important, is that failure is not analyzed. When you don't analyze failures, you are doomed to repeat them. And I know that's something that's said similar about history, but it's very true about failures, that if you're not analyzing root cause of analysis of certain failures, you're just doomed to repeat them again. So when you look at this chart here, how does this site perform? Here we see some of the results of maintenance schedule compliance, planned maintenance, and the like, and they're all below the accepted benchmarks. Maintenance compliance should always be above 80%. Planned maintenance should be the same. Emergency work is generally accepted at less than 10% for a site. Backlog in weeks of work should be 3 to 4. Craft labor utilization should be much higher than 70. Mechanic wrench time, because of all the breakdowns and all the unplanned work, 15% is completely unacceptable. It should be at least in the mid-30s for most sites. PM compliance should be well above 80. Proactive work scheduled should almost be in the 60 to 80% range. Mechanical availability should be much higher. And again, all these metrics indicate that this is a very reactive site, a site that is just not ahead of its failures, and the failures are ruling the day. And what's the impact of reactive maintenance? First and most importantly, it provides an unsafe working environment. When the equipment is not reliable and mechanics are reacting to unplanned work, they're at high risk for injury. It has been shown in several companies that the more reactive a site is, the worse the safety record is at the site. Of course, you're also possibly impacting the community by having spills and other issues from equipment failure. Unplanned downtime, which really hurts the business. Quality issues, which require rework. Missed customer orders. A storeroom that has much more spare parts in it that's required. Maintenance doesn't have time to do precision maintenance, such as doing alignment and other aspects that are required for good long-term performance of the equipment. Little planned maintenance. Inefficient use of maintenance labor. Everyone's moving basically to the next big job, the next big breakdown. It's kind of like the analogy of when you see small children playing soccer. They all tend to move with the ball, and that's what happens to the maintenance group. They all tend to move to the next breakdown that occurs. And of course, shortened equipment life means higher equipment expenditures. Now, so why do I mention all this work around reactive maintenance? Why is it so important when it comes to root cause? And I know there's a lot on this slide, but what the slide shows is there is a connection between the maintenance work process, the basic work process of prioritization, planning, scheduling, executing, and closure, and the reliability work process, the process that sets up the right care for the equipment. And the place where the two connect that I'm showing in my example here is, number one, at the failure mode interface. In other words, once you have very good history, that history needs to be analyzed to understand what the failure modes were and what can be done to change that care that's being delivered so that failure does not occur again. And then it's connected again at the scheduling side, making sure that the right tasks go into the maintenance work process so it can be executed and prevent failure. So we're really going to talk about today about this failure mode interface. This is where root cause analysis is important, and this is why it's so important. If it doesn't exist, the maintenance work process and the reliability work process become completely disconnected, and that does not lend itself to the continuous improvement of equipment care, reduction of failures, improvement of uptime, reducing costs, and all the other things that are so important to each and everyone's business. So what is the path forward? The way out of reactive maintenance really depends on eliminating defects and scheduling and doing efficient planning and scheduling. Again, going to that previous slide, knowing what the defects are, rearranging the care or redesigning the care, and then making sure that care gets executed. So good planning and scheduling. So you can meet the safety and uptime goals, ensure that all failure modes are included in the equipment care strategies so you're not surprised by a new failure. Continue improvement, so every time you analyze failures, you continually learn about what needs to change and what you can do to improve the equipment performance. You can remediate the top 10 or top 5, whatever you choose. You can identify the bad actors and repeat offenders and eliminate them. And most importantly, ensuring that proactive work gets scheduled and executed. There are many defect elimination tools, and I'm sure many of you on the call have used one or more of these. 5 Whys, root cause analysis, the fishbone, the Pareto analysis, or FMEA. They're all very effective root cause analysis tools that can be used, but the issue is you have to use them for the right type of issue, and that's what I'll be describing here in a moment. What are the issues? Why doesn't root cause analysis get done? Why is it so difficult for sites to get root cause analysis going? Number one is there's not the right culture in our facilities that really focuses on getting down to the root cause. They tend to just want to move on to the next thing, fix something very quickly, maybe not really remediating the real issue and just moving on. There are attitudes of the blame game. Oh, it's not the care's fault, it's not the mechanic's fault, it's not the system's fault, it's something else. They just throw it off to something that really doesn't relate to the real failure, the root cause of that failure. There's no triggers. I'll describe them here in a moment. Triggers are very important so you don't overwhelm your staff. Also, we tend to mismatch the method with the complexity. I mentioned 5 Whys earlier. 5 Whys is certainly not appropriate for every failure, but for many failures on the production floor, on the manufacturing floor, operators, first-line leaders can use 5 Whys very effectively. But unfortunately, we tend to use the most complex tools for sometimes the most simplest issues. And when you use a series method, it's only as strong as the weakest link. And what I mean by that is, when you use certain methods that deal with just one cause, if one of the reasons you've come up with of the root cause is wrong, the whole analysis falls apart. So it's real important that it's done correctly. Sometimes the failure mode isn't, and the mechanism chosen is just not correct. There's not enough the right experience in the room. The right people aren't involved. The causes may not be comprehensive enough. The actions chosen are wrong, or they're not they're not correct, and of course when they're not correct, you just tend to relive all these failures. Some other factors are inexperienced facilitators. You really need to learn about root cause analysis and the skills that are involved to become a good subject matter expert in this field. And a lot of times it's given to someone who is not an expert and doesn't lead the best analysis for a particular issue. We don't obtain the right information and evidence. We have a tremendous tool in our hand today, and it's our phones, where pictures can be taken of the situation and really help the root cause analysis. Resources are not sufficient to resolve the actions. We don't put the right people in the room really to resolve the issues. The organization's not strong enough really to resolve, because in many cases it's an accountability issue and it's not approached. Action traction is not performed well. In other words, once the root cause analysis is done and results are identified, there's no follow-up. They're not accomplished, and so you tend to just relive failures from previous poor efforts. So what's the work process? Let's get away from the negative and move on to the positive. The first steps in the root cause process I call the preliminary steps. It's when the event first occurs. You decide if you can do a floor-level problem solving with it. If not, then you get into a set of triggers, which then determines how it should be done. You collect data, so you're prepared for the eventual analysis in the meeting, and then you hold your root cause analysis meeting where solutions are proposed, validated, and assigned. The next steps is implementation. Actions are placed in what I call action traction, or some system to track who's going to be doing it and the timing. Actions are taken based on complexity. They're completed. Evidence is presented to show that, hey, we actually did what was required by the results of the root cause analysis. And finally, we have the closure section. They're updated. The actions are updated. The root cause analysis is closed. Metrics are issued overall for the program to see how the site is progressing. And there's really a commitment that's by leadership, often to commit to continue to do these types of analyses. So again, my comments to you here today will be involved in these three areas: preliminary, implementation, and closure. Let's talk about the preliminary. Leadership sponsorship has to exist to get a good root cause analysis going. If the plant management team does not support identifying root causes, eliminating failures, it really won't go anywhere. And of course, expectations need to be raised to believe that every equipment failure can be prevented. When I first started in the chemical industry, it was always thought that injuries injuries were not preventable. We think totally different today. Obviously today, injuries can be prevented. And the same thing around equipment failure. It can be prevented, but you have to believe in it. It has to be part of the philosophy in the facility. And root cause analysis is not just a maintenance reliability role. It's a plant-wide function. It involves operators, operations leadership, engineering, and other groups in the plant. Now, if you have a reliability group, they can act as stewards and promoters of a good root cause program. And again, I'll give some examples here, but triggers really are important to have because it kind of dictates the priorities and the methods that you'll use. So let's talk about triggers. There's several ways to go about that. Some are based on failure, and again, some are based on how many can be done in a year, and some are based on the magnitude of the consequence. In other words, on the magnitude of the consequence, if there's a loss of production for more than a day, then a root cause analysis should be done. If there's an EHS consequence of an injury or a near miss, maybe then you institute a root cause. Or if there's a large cost consequence, magnitude versus budget, then you would institute a root cause analysis. And for everything else below that, you use other methods that are quick, done on the floor, and are much easier to apply to the particular case of the root cause. So again, triggers are what prevents overload. If you don't have a good set of triggers, then you won't be able to manage the load of failures that a site can sometimes be faced with. Sometimes there's one done on complexity. This is one I particularly like. Tier 1 is the use of 5 whys, and Tier 2 is 5 whys or an RCA facilitated by a staff member and it is tracked. Tier 3 is a triggered fishbone or an RCA for a team. And Tier 4 is a serious consequence or near miss where there's a formal RCA. This is another set of triggers that you could use to facilitate a good process during the year and not overload the staff. So again, triggers are very important, but unfortunately rarely used. Again, I talked earlier about 5 whys. It's a great tool to use for Tier 1 and Tier 2, as I just mentioned. Here's a very simple one for a crusher that had a failed component of an oil inlet, lube inlet line. And again, going through the 5 whys by asking a why 5 times, they developed a root cause statement that it was the wrong material, gasket material. I mean, it doesn't take a whole room of people to do this. This can take 1 or 2 people. It can be a mechanic and his supervisor or her supervisor, and then very simple actions that can be taken. This does not have to be a formal root cause analysis for Tier 1 and Tier 2 type exercises. Again, the smart use of triggers are important. Tier 3 and Tier 4, it's a whole different story. Obviously, they're greater impacts, greater magnitudes, and I'm not going to try to suggest one of these root cause analysis methods over another. They're all good if people are trained to use them and they're disciplined in using them. So whether it's a polymer root cause, whether it's cause link, whether it's taproot, whether it's cause mapping, whatever it is, they're all good pieces of tool. They're all good tools, but really require discipline to learn them and to use them. And again, root cause solutions must be comprehensive. In this slide, I show all various reasons of which root causes categories should be considered during the analysis. Many times, the experience in the room leaves out 1 or 2 of these, and because of that, the root cause solution may not be adequate. So it's important to have good experience in the room, people that are trained, they know all the types of root causes that can occur, and they need to address them at the meeting. You just cannot deal with the obvious that you think one person sees. They must be comprehensive. In the implementation phase, it's always good to designate a maintenance reliability resource to maintain and manage the process. It can be another individual in the organization, but from my examples, what I've seen, these individuals tend to do the best job. I would always aim for 10 to 12 failure investigations per year per staff member, maybe 1 or 2 a month at the most. No more than 15 overall triggered events during the year. And also, there must be consistency in what I call the height of the hurdle. In other words, when someone says they completed an action from a root cause, they should have to show evidence, and the person evaluating must be certain that it was implemented effectively and that it is working. So everyone should have the same height to prove of the hurdle to prove that they accomplished the solution. In closure section, it's always good to have a great tracking tool. Of course, you can do this on an Excel spreadsheet, but there are certainly tracking tools for actions from a root cause. And if you're using root cause software, there's always sections in the software for tracking actions. Good to, obviously, there must be responsibility for reporting metrics. And metrics should be reported on a monthly basis, along with an annual summary. And management should always reaffirm its support, because this is hard work, and it really takes discipline and diligence to have a good root cause system be effective. So what kind of metrics would you use for a root cause system? Of course, let me make sure that we understand the difference between leading and lagging metrics. Leading metrics measure the activities of a system. Lagging metrics measure the result of the system. So for a root cause analysis, you might want to measure the number of new RCAs, the number of root cause analyses that are open and closed, the number of action points that are open and closed, and the number that are moved from preliminary to implementation. So again, what you're measuring in the leading side are all the activities of a root cause work process. On the right side, on the lagging metrics, you're measuring all the results. The cost of the events, mean time between failure of rotating assets, the number of equipment strategies revised, and the percent of bad actors and other high failure pieces of equipment that an RCA was performed. So again, important difference between leading and lagging. Leading are the activities and lagging are the results. So what are the barriers for doing this? Of course, it starts with leadership. If your site management, your production management, your maintenance management is not in support of this, it's just doomed to failure because it's very hard work and it takes attention. And another barrier is existing failure accepting cultures. People say, well, equipment failure is just part of the job. Again, injuries were part of the job too many years ago. That's certainly not the case. Priorities from reactive work. Well, we can't do a root cause analysis. We don't have time. We have something else that failed. A lack of skilled facilitators. They're given the job, but they're not trained. It's good if you're working with a piece of root cause analysis software to use the vendor's training to learn the software and how to do a root cause analysis. Lack of consistency in execution. Too many shortcuts. They're not done the same way. And because of that, the results are faulty. Care plans not being modified. In other words, once you have a result from a root cause analysis that says, hey, we need to add a PM for this pump, and the PM never gets put in the system, well, the root cause analysis was useless. And you're just doomed to have that same failure in that pump again. So what are some of the expected results? You can expect a 1 to 2% increase in what we call OEE, or the efficiency, after 2 to 3 years of any improvement of an improved initiative. But what you'll see is a reduction in the impact of the consequences of failures. You should see a reduction in the number of failed assets. Hopefully a reduction in bad actors, although in theory you'll always have bad actors. There's always going to be some that will rise to the top. A reduction in repeat offenders, higher unit and plant productivity, lower maintenance costs, and you'll have resources that are available to do more than just react to failures. They'll be there to do more, have more time to perform proactive care, and that's really where you start to turn the ship around, is when your maintenance people are doing proactive care and not reacting to equipment failure. And always remember, as some failures are resolved, others will always appear. So in closing, we'll have plenty of time for questions here. When you have reactive maintenance, it severely impacts the goals of any asset owner negatively. And to move from reactive to proactive cultures, you've got to get ahead of failure and understand the root cause of failures. And you need to effectively plan the equipment care that is supposed to eliminate those failures. Again, multiple issues exist why an organization cannot implement a good program, as I just went over. It really starts with leadership. You need a good root cause work process that everyone understands. It's supported by well-trained facilitators. You need to use the triggers to manage the workload and direct certain issues to plant floor people and not to whole rooms of people, which take up too much time. And you need to look at leading and lagging metrics to indicate how good you're doing in your root cause analysis program. So that's my brief presentation on root cause analysis and how it can help you. I guess now we're prepared for some questions.
Thank you so much, Dave. At this time, we will be open up to any questions anyone has. All right, our first question here. Should we really limit ourselves to only 12 to 15 RCAs per year? In a truly reactive culture, there will more likely to be much more causes for RCA to be performed.
And my answer is you need to filter those through your triggers. I like to know that all the failures you're hunting, how many of them took the facility down for more than a day? How many cost more than $50,000 to repair? The problem is in many sites that, yes, you're right, you will have more than 12, but you need but the staff cannot handle more than that if they're done correctly. And the way to minimize that is to have effective triggers that you filter through to say which ones really deserve the full-blown root cause analysis work. Next.
Okay. All right, it looks like there are a few questions, but I think they will be best answered through email. I would like to thank everyone for joining us today, and thank you very much, Dave, for presenting.
My pleasure.
Everyone have a great day.